learning here, then you learn the data science, machine learning, then you see how these two technology integrate. This become MLOps. And we Linux Code is specialized in this, and we are the first one who have launched the MLOps program long back. Okay, but this is again great area to be explored and a lot of benefit. If before you go to this area, you should know the DevOps and Jenkins. That's what we are learning here. Okay, so so let's start, guys, for today's class. What we are going to do today? Okay, so today the plan is something like this, like this. Okay, the plan is we would like to do something. Again, let me again explain the story. Okay, we have a developer, and developer is writing a code and creating the app. Okay, and the way I explained in my last class, okay, mostly in the today's world, okay, all the app we would like to launch in a way, so it would be containerized. Means we want to run the app in the world of container technology, like for example Docker. Okay, so what we can do, we can this app is just a code, right? So this code we can put inside one container image. Okay, and those containers we have to create by ourselves. This is custom image. So there we can use a Docker file. That what I show you in my last class also. So nowadays this is a kind of responsibility of the developer to do two things: create a code for the app, and second, create the Docker file. Okay, exactly. This is what exactly we did in my last class, right? And after we do so, after they do so, they will upload both the things in SCM tool. Again, I'm using GitHub here. Okay, SCM tool. Okay, and now what we can do, as soon as something upload in the SCM, okay, we want somebody here that's called Jenkins. Okay, and Jenkins is keep on having a on this SCM tool. How they keep on going? So we have set a schedule that's called poll SCM. We have done, right, and we set the interval of, let's say, 1 minute. Every 1 minute they keep on checking, keep on watching, something new gonna come up. And as soon as something new gonna come up as a new code or new data, okay, they will download. This called pull. So here these guys will push and they pull. That's what we did in the last class. Okay, and here what they pull, here what they pull or download the app code plus the Docker file. Now it is your choice. You want to pull in this computer, let's say computer number IP 100. Okay, but the best practices is, I told you in my last class, this is the Jenkins server. They will do the overall management, also known as Jenkins master node, or whatever you want to do with your code, you always want to do in the slave node. So instead, this pull is done by master node. Okay, this Jenkins will allocate this part to other node, that is the slave node of the Jenkins. So we have a slave node. That's what we prepared in my last class. And Jenkins server say, okay, we keep on checking. Okay, and as soon something new come up, you will go to GitHub using a Git tool behind the scene that you'd install in your computer, and then you will download this code, both the things. And here we are giving you one responsibility that you have to run a job. So job we will create in the master node. So creation of the job or the management of the job will be done in master node, but running part or executing the job, that is also known as building the job, well, let me use the word run, will be done in the slave node. And what they do here in the slave node depend upon what we write in the job. Let's say in this case, I want to build the build the container image, or let me use the Docker image. That's what we're doing. So this system will do two things. They will build the image, plus they will push the image to some centralized location that's called Docker Hub. So other team can use it. Okay, so I can say this job is having one responsibility. The responsibility is build. Okay, that's what this job is doing, and this job is running in one of the slave node. So this is what exactly as we did in my last class. Okay, but I am again explaining this concept to you because I want to extend this particular diagram plus add many more facility on the top of this. Okay, then after this job complete, this is called build job. Okay, then we can do one more thing. This job, this is called build job, okay, will trigger one more job. And that second job, let me write a job number here. First job, let me use the name build that we create in the master node. Second job is that whatever image you created, we have to test at does this image is working or not. Image is what a container image, right? And how to test? We launch the image, we run the image. And you guys know if you have any container image and if you want to run it, it becomes a container. So what I want to do in second, I want to test. So I want to create a job that will help me test. And what the test? What an image we build in the first job here. Okay, from this image, I want to launch a container. So I can see everything is working fine or not. Okay, and who will launch this container? I can take one more slave node. Let's say this one. So this is slave node one. This is independent node running somewhere in some, maybe in some other cloud also. And this node duty is help me to test by running some job. And what they do, wherever they upload the image initially in the Docker Hub, okay, this node will download the image from here. So they are downloading the Docker image. This could pull the image over here. Okay, after the download, what they do, they run the container. And if the container runs successfully, okay, how we know container runs successfully? We'll test something, and how we test we'll see today. Okay, then it means the last job what you asked for build, it was running fine. Okay, so the second job we are going to run as a test job, and this job we are running a different node. This job we are running in a different node. Okay, so we have different node. Everyone has their own responsibility. Okay, and whatever they're doing, accordingly we install all the respective tool. For example, here node 2 does not need to go to Git, so we don't need to install any Git software here. But here we need Git. Node 1 need to upload something in the Docker Hub, so here we have to log in to the Docker Hub. But node 2, we does not need to log into Docker Hub. Maybe let's say because they upload in the public repository, so node 2 will directly download the image without login. So depend whatever the node responsibility would be. So we always create have a multiple slave node, and normally we categorize slave node based upon their responsibility, plus based upon their use case also. So it's a slave node 1, your duty only to do build, that's all. When it's a build here, I mean to say create a Docker image from the app and the Docker file uploaded by the dev team. Node 2, your duty is only to launch the container by downloading and test it. That's all. And whatever tool you need or commands and software you need, I will install in your computer. Okay. But here, okay, who will run job 1? Okay. So who will run the job 1? So job 1, guys, run somewhere in the node 1, but who will run the job 1? Either you can go manually run it, but it could be a manual process. So I want the job run automatically. Anything you want to run automatically in the job, we have to use trigger. And here we use a trigger in my last calc of Paul SCM. So what I do, I set in Jenkins every minute you go to GitHub. As soon as you see some new code come up, automatic trigger it.
दोस्तों आपको बहुत सिंपल है, आपको
So here guys, this is running automatically.
कि created
But who will run job 2?
pipelines of a web app using Docker, Jenkins,
Okay,
AWS.
that again we did in my last class. Okay, so job 1 is running, and if the job 1 runs successfully, okay, so job 1 is the one who will trigger the job 2. Stable, same thing. First job is stable and success, then we trigger job 2 automatically. That's what we did in my last class. Okay, so in this case, job 1 automatically running the job 2. You don't have to manually go there. That's what you guys have to do. And this kind of trigger is called downstream upstream, right? So we are going down. So this is known as up and this is down. Upstream, downstream. Trigger we use in my last class, right? So till here guys we did in my last class. Okay, and working very fine. But there is a lot of component we have to add here. Okay, to make this part more interesting. But after we do so, I need to add one more point here. Let's say after my job 2, job 1 is building the image, job 2 is testing it, and if it is tested successfully, then we are good to go. Whatever my developer has created app and the Docker file is absolutely working fine. And why are they creating the app? Because they want this app to be launched in the production environment. So the public guys, real clients can use it. So maybe here we have a real clients, my customer publicly, and I want they can see my website. So for this, what we can do, we have one more computer we can add here. In this computer, okay, because this image we already tested. Okay, what I downloaded from Docker Hub. Who tested? Node 2 tested in job 2 or test job. So if we test is successful based upon whatever test you write, I'll show you some small example of test. So if it is successful, okay, it means whatever we have done is working great. It means this is working great. So what I can do, I can my image is good to go, and I can take this image again from the Docker Hub, put in this computer, okay, and launch it. Okay, and after launch, obviously my customer can go and see this website. Okay, so technically what I'm going to do, I'm going to launch my app, that is also known as deploy. I'm going to deploy the app for my real world, public world. That's also known as production world system. There's one of the last plan. So customer can see, and we want to show the customer that's what we're looking for. Now it is up to you, okay, launching this, because right now this is container images, right? Here we launch a container on the top of Docker. Okay, Docker. It's very simple to implement the Docker, set up the Docker. And because my plan is only to test, to run the container and things working fine or not. So having the Docker setup can be a simple, fast way to implement and set up. Okay, but in the production world, right, using the Docker might not be a great choice. Okay, so instead we use a Docker, we can use other tool and technology that is very mature. Okay, and the technology what I'm talking about here is Kubernetes. Or those who know OpenShift, you can use OpenShift also, something like this. Okay, So Kubernetes is again tool or technology, okay, that is meant again for container world. So any images you have, if you want to launch a container, instead you launch via Docker, if you can launch via Kubernetes or the OpenShift, okay, it is a better way because they give you lot of powerful benefits, okay, to launch. So those who know Kubernetes and OpenShift, that my training is going on. Okay, you guys know the power of Kubernetes and the OpenShift. So you can get all the power of Kubernetes and the OpenShift. One of the interesting power of the Kubernetes and OpenShift is the deployment. So there is a concept called deployment study. Also a very interesting demo today in this entire flow. Okay, let's make the Kubernetes and OpenShift very unique. There will be hundreds more benefit, but this is one of the interesting capability they have. What is this? I will show you in a minute as a quick demo. Okay, that's what we can do here. So finally, my image for the public use, so if my customer can see the website, we can launch in the Kubernetes and the OpenShift world. Let me give some vocabulary here. Okay, here. So this computer is mostly known as build server because it is we are using for build purpose. So they can say this is node known as build node or build server. This node we use the word called test server or test node. Okay, and this node we use known as deployment node, deployment server. Okay, sometimes also use the word of production servers. Okay, so these are the basic term we use. Okay, that's what we have to use. But if you know a little bit about the Kubernetes, okay, so in the Kubernetes itself is a guy's big system, right? So Kubernetes also have a master node, multiple slave node. They work together as a team known as a cluster of the Kubernetes. Okay, and if you want to use a Kubernetes, then we have to use one computer that is called user computer. Okay, and from this computer we will contact to the cluster. Okay, and what I want to do, we can do here. So this is called Kubernetes admin computer or user computer, where my admin team sit and send the instruction to Kubernetes and say, hey, this is what I am looking for. Okay, so it means whatever you want to do in the Kubernetes, you don't go here. It's called master computer. You don't have to go in worker or slave computers. They work together, become a team. You don't have to go there actually. It's one-time setup we do, or some of the team will do for us. Okay, after this we don't go in this particular area. Okay, that's what we don't go in this pink area. We always sit in our computers, and from here we connect. So we can say we are user or client computer, and to connect we need a tool called kubectl. It's a client tool, and this is the only tool we use just to communicate or send the instruction whatever we're looking for. Okay, similarly, so in our case, in Jenkins, so this is your production environment. So your production system or the environment or the server, whatever you say, or maybe you can use the word production environment, is this pink box. Okay. But who will control this environment? Your one computer, or one node will control this. Same thing we're gonna do here. Okay. So this is your production environment running Kubernetes or OpenShift setup. Okay, who will control? We need one computer, so we'll add one more computer here. Okay, installed with a kubectl command is a user command or the admin command, and this is a command who will go and contact to Kubernetes server and say, hey, I am looking something that you will go and pull this image from Docker Hub and launch a container. So my client from outside world can go and come and see your website or the container or the app. Okay. The point is, who will send this instruction to Kubernetes operation environment kubectl. So where is the kubectl? In one of the computer. But who will control this computer? Again, Jenkins. Okay. So here Jenkins will control. So I'm going to write a third job. This job is called deploy job. Okay. Where Jenkins will go to this node, and again this become a slave node. So Kubernetes server won't be a slave node or cluster. Your slave node for Jenkins perspective would be your Kubernetes client computer. Which is client? This is a client. When I say use client or user, here the same thing. So this computer will be where kubectl command is there, where they know where the Kubernetes is, are the are the one of the slave node of the Jenkins. Okay, because this is system where we run the kubectl command. This is the system where they contact to Kubernetes server. They know where it is. So your app will be launched in the Kubernetes or OpenShift version. But who will control this kubectl command? Who will tell when to run, when not to run? Your job. Okay, and to run any job in one of the computer, we need a slave. This is called Jenkins slave we need. Okay, so if you notice guys here, now we have three nodes as slave node. One is this one where we build the thing, one this one where we test the thing, and one this is where we run Kubernetes client command. Means the command through which we send the instruction to the Kubernetes running somewhere in the world, does not matter where they're running. It means my third job, okay, that's called deployment job, is running in the third computer. But who will run the job? Manually or maybe can run automatically? So when my second job runs successfully, that's my test job. If my testing done successfully, then my second job is a one who will contact to my third job. So for second perspective, so the up job upstream and third is downstream for the second perspective. They will go and run the third job, second will run the third job. How? By trigger. So again, we write in the second job, if you run yourself, if you was stable, successful, then trigger the third job. So third job will be automatically run, right? And when the third node 3 will run kubectl command, is a user command. They send the Kubernetes cluster and say, hey, I have an image somewhere in the Docker Hub, download this image and launch a container. And those who know Kubernetes, they know in the Kubernetes container is technically known as pod. So they will say, go and launch the pod. As soon as the pod launch, your client can see the site. Okay, so that's how the process. So again, guys, if you notice here, okay, it's end-to-end automation, right? So as soon as my developer writes something and upload from this end, okay, he reads to the customer that end. So it's a complete end-to-end automation. And in the end-to-end automation, if you very quickly draw, my developer will upload something in GitHub or other SCM tool, then my build job run, then my test job run, then my final deployment happen, and then your customer can go and see the site. It's completely end to end automation is a kind of pipeline we have created or process we have created for the automation. Okay, some of the part we did in my last class, but I will quickly show you as a quick summary again in the demo. But this is a complete end-to-end pipeline we created, but do in the automated way. Like I said, it became a very big project. I'm showing you today this complete project. Okay, so it's a good to have this level project, and I highly suggest. Okay, In the real world, if you're looking for the better job or better profiles, enhancement career, okay, skills matter. That's all. What you've done, what your degrees does not matter at all. Skill matter. If you know the things and problem to solve in the real world, you know this level of projects, that would give you a growth in your life. Okay. So I suggest guys, after understanding this project, set up this project, create this project by yourself and create a very powerful blog article, put in a resume, put in a LinkedIn, this level of project you've created. It will give you a huge benefit, guys. And I'm not saying for sake of saying, I've seen other students, other candidates from last batches, after they presented this level of project, okay, they get a lot of offering in the jobs. Okay, especially if you put in the LinkedIn, the, hey, I created this level of project. Okay, so a lot of benefit you will get automatically. So only here to showcase yourself, that as I'm trying to keep on telling you again and again. Okay, so that's what we do here. Developer is a real human being, customer is a real human being, GitHub is some product already there in the market. Only thing we have to get this three, one, two, and three steps are known as stages. So these are the stages we have to set up, and every stages has been done by job build, job test, and deploy job. Okay, there can be many more stages in between, or maybe less, depending upon the requirement. But this idea will help you to create any other projects also as automation project. Okay, so today's class, guys, this is a high level architecture I showed to you that we are going to set up. But inside this architecture, guys, there are a lot of small pieces. I will explain you and see how powerful it is. Only prerequisite for today's part is you should know something about Jenkins that you know already. Okay, and for the practical perspective, you need two things in today's demo. Okay, two things you need. You need Jenkins master slave system, and obviously you understood, I think from this diagram, I need one master, this is called Jenkins server. I need three slaves, one for build, one for test, and one for deployment. This is the we need from Jenkins perspective. In my last class, I launched one master, two slave. I'll show you one more slave very quickly launched. Okay. And second thing, I need a Kubernetes setup. And this is not the Kubernetes training, but those who are there in the Kubernetes training, they know how to set up the Kubernetes. Okay. And by chance, if you want to learn how to set up Kubernetes, if you don't know how to set up, okay, and for doing this practical, so what I'll do, guys, I have delivered recently one master class on multi-node Kubernetes setup where I explain you a lot of concepts of Kubernetes and plus step by step how to set up the Kubernetes setup cluster. So today, okay, you don't need much knowledge of the Kubernetes. For doing this practical, you need Kubernetes cluster. Okay. So if you don't know Kubernetes, guys, that's okay because nothing much gonna come up. Okay, but to when you do this practical, you need the cluster. So I ask my team, they will share that videos to you, everyone over here. So first learn the concept of how to set up the multi-node Kubernetes cluster. Okay, set up the cluster, and then you will perform this entire setup. Okay, but don't take this in a way that hey, I don't know Kubernetes, so I can skip this tutorial. No, don't do this. Okay, because there will be nothing much about Kubernetes. Only in the last portion is going to come up where I show you one or two simple commands to integrate. Okay, but the remaining portion, the flow is very important. That's what you have to concentrate. But my point is, for today's demo perspective, I need a Kubernetes cluster. Okay, and I think this both the thing I have in my AWS cloud. I asked my team, I think they have uh, launched and upped. Okay, so I can show you in this demo very quickly. Okay, so let me start, guys, from here. Let me at least see what is there in the build server, then test server. Okay, so let me do some part we have done already in my last class. So it will be a quick revision. So what I have right now, right now, so Uh, we have Jenkins OS running or slave we have. So let me change this name. Let me say this is Jenkins master. Okay, is running right now. Okay, and we have two slaves. So let me search very quickly here. Only Jenkins. So we have a lot of computers running. So this system we have. That's what we have said in my last class, right? And if you look over Jenkins master, okay, so the IP of this guy is this one. So let me connect. Port number 8080, I think is the port number. And username. Okay, so this is the Jenkins master I'm having. So let me draw here. So in my case, this is Jenkins master. Jenkins master. I'm just writing the IP address so there will be no confusion. So IP address for master is 138 in the last. Okay. And we have slave already connected in my last class. Very quickly, let me check. So I click on manage Jenkins. And in the node, okay, the two slave cases is connected. And slave one, okay, if you see the log, so it is failed. Okay. Why fail? Why fail? Mostly they try to connect initially with some IP, and today because my system was down actually, slave was down, and if you shut down the computer and again start in AWS, IP will change. We can make it permanent, but different point, but IP change. So right now my new IP for slave one is this one. Okay. So what I'm going to do here, I'll go and configure one time. Okay. Only thing is I'm just changing my IP address. Okay, otherwise remaining portion would be exactly the same what I configured in my last class. But one more small thing I'm doing, I told you in my last class, is good practice. Okay, set the labels. So I'm setting this guy a level called build. So I'm setting up the one slave here. In my case, the IP of the slave is 212 in the last. Okay, and giving the name called slave one. Okay, but important point is the label because we allocate the job per level. That's what I show you, but I'll show you one more time. So level for the system is my build, or whatever name as a good label you can give. Okay, so that's important here. Okay, so let me relaunch my agent. So you guys see that now they authenticated successfully, they connected, and finally your slave is up. Fantastic, right? So slave one is working fantastically fine. Now let me move to slave two. This is slave two. Okay, it is again also having the same issue. That's what they're asking to relaunch. So let me go and configure, and according to my uh, system, IP again change. So in the configure, only I'm changing the IP, otherwise remaining setup would be exactly the same. So IP is 175. So the next system is slave 2, IP 175. Okay, and here I'm just giving just a name. My plan is to use as a test perspective. So let me use the label called my test. That's what my plan for using the second system for test. So I'm changing a label, just a name. Okay, so the level is my test. Okay, so we have here. This is also online. So two slave we have working fantastically fine. So this is swap guys, so don't worry about this. So this is not so much very critical. Okay, but it's both are online. Now if I go to dashboard, we have created some job guys in my last class. Okay. So first job that I created in my last class is deploy a project to build. So Docker project to build. That's what I created. And in this project, what I did, in this job, what I can say, what I did. Okay. So if I just configure this job, I say your duty is, okay, your job one, your duty is go to GitHub. That's what we given here as a message. This is URL of the Git. So this is the last class we have created, right? So go to this GitHub. My developers keep on uploading two files, your app plus the Docker file. Okay. Go to this GitHub. Even though guys, sometimes good practice, whatever GitHub URL is, we can also set here as a Git project details. Okay. So what is benefit of giving this name here in Git project? So you know what happened when the configure part, right? You can see there's no project name, but as I save this project, you can see something. Save this project. You can see there's one link gonna come up. It was not there. There's a quick link for this website. You don't have to go and copy paste again and again. So there's a link gonna come up. You click here, you land it to this project. So this is a small thing, but it's one small facility. So sometimes you want to give a project link. So you know when you want to open the project, just go and open the project directly from here. Okay. So so we say this is our Git project, and this project will run only on a node that has a level my build. That's called first node, that is up. Okay, this job gonna run here, and what this job will do? First, this job will download this Git code in this project workspace folder, and then okay, and then plus from where they download from GitHub when every time they keep on polling, they keep on checking to GitHub. So we set a poll ACM. So you don't have to click this now this job again and again. So they trigger. Okay. And they download, they do these three things. Okay. So whichever the area they download, say here I'm going to run the build command. So the dot means current folder where the workspace they download, they build an image. They change the image name to Docker IO so that we can push in the Docker IO. That means in this computer, slave one, you have to log in with the Docker Hub. And I think my last class I already log in. So I think it's maybe still logging. So we can successfully upload that. Okay. So the slave system, you need multiple things. You need a Git command that I installed. You need Docker command that I installed. You need Docker login. All the things we did in my last class. So it will quick revision for you. Okay. So it was working fantastically fine. And what else? Nothing till now. Okay. And one more thing we did, guys, in my last class, when this project runs successfully, then you run downstream project. Okay, which one? The project to production. Okay, but today I changed some small thing here. My plan is to not to production. My plan is to run the test job. The logic is almost same. Okay, so let me do something here. Don't use this project. Let me delete this, or let me do some copy here, code. So let me do a small change because my plan will be changed today. Okay, let me take this commands, what I used in my last class. Because my plan is to delete this because I didn't change something here. And let me go out. Okay, and this project, second, I would like to delete. I don't want to use this. Only one project we have. Okay, to be used. This called project to build. First job we have, and second job is I want to test. Okay, and for test, what I'm going to do, I'm going to create a new project. Okay, and let's say Docker project to test.
After B run, then C run.
This style.
Okay, so it
Okay,
should run while
and
not showing you here.
copy.
Let's wait for some time.
Okay,
Or
and here this
let
project.
me go to dashboard first.
Okay, I want
Then
this
I
project to
saw,
run
okay,
automatically.
so
Second project,
last
just
21
called
second ago, right?
test
This is
project or
already,
test job. So this
it's
test
run
job will run
actually right now,
automatically. So I
but
can
they're not
see
showing
here
you
I
there.
am going
It's
to
not
set
updating on
a
the real
trigger
time.
on you. Okay, you have to check other project who are building. Okay, and the project name that is building is
Not it. I think it takes some time to
Docker
load, or maybe
build
refresh the
project.
screen. But yeah, this is the one page you can
Okay,
see.
your
Now
Docker
from
build
here they
project.
give you this
So
screen.
your
You
I'm
can
best
click on the
creating guys this
console
job.
and get the output
You
there
keep on
on.
watching this guy, this up guy, you know, it's becoming down for respect to build. If this was stable condition, if it is stable, then run yourself. Okay, there's a trigger. So this job will automatically run. That's what I did
So
in my
all
last
the
class.
common things, all things I can very
So
quickly
where to
explain. I
run this
can
job?
rerun from this stage. There's option rerun.
You run the
Only
job
this
in
particular stage
slave
I can run.
number two.
Or you want to add more
So I can
stages,
set here
there's
this
also
job
sometime even on a
would
step.
be
I
run
can also add the step
on
from there. Means like a new job.
slave two, my
So let's say
test.
this
That's
is
what the
job
level we
number
given.
D I want to
Okay,
create.
and what to do in this job? You run some
So from here
commands.
also we can create that
Which
link to the
command? The
jobs
same
or
command what I
masters.
did in my last class. Same thing I'm
Okay.
running right now.
So
Just
that's
for quick test. It means if you already have the container running initially, terminate this and then launch a new container, expose the port number from the image, and this image was the one who created in the last stage. Okay, so almost same thing what I did in my last class. Just you check, then I can show something good on the top of this. Okay, this is what has happened. Now if you go to dashboard in this build, you can see the downstream is this test one. It was new, so you can see this line means it's not yet been run. And in the test job, the upstream is this one. The green thing means last time there was successful. Okay, so it is working fine. So let me run this job, guys, and how to run. Because everything has been automatic. That was the last demo of my last class. So you don't have to run by yourself. It will run automatically. If you guys see this project is not yet run, and this project ran 5 days ago. But now you see this job will run automatically. How? When something change here. And how change? So my developer sitting on the laptop, let's say I am a developer. Okay. And the last class, we have changed something in my local computer. Docker training. This was the folder I created. Docker, Jenkins, Docker. So this system where my developer is sitting and they change something in the code. Let's say they come with a new version called 5, new changes, new color. Okay, they change the code. You guys know when they change the code, we commit always. Let's say new dot made all the file whatever change, and that get push. So this code from my laptop go over here, and then everything to be automated. And really automated. So finally, in your test computer, okay, your container launch on port number 80. And my test computer running in slave 2, and IP of slave 2 at this point in time is this one. So right now in this IP2, okay, port number 80, nothing is working. But that's almost very small thing. Okay, slave 1, slave 2, both the computers using Docker. So in the last class we launched the Docker, but I think I might not have started the Docker service permanent. So thing will fail. So let me check very quickly, right? So I'll just log into this machine directly, slave 1. And last class we started Docker, but I started the service, I think temporary, means after system shut down, my Docker automatically stop. Or because my system shut down actually. So what I'm going to do here, Okay, log into the root account first and check docker ps command. Okay, it's working. Or let me check the docker images. Yeah, it's working. So my service was permanent. I think in my last class I make it permanent maybe. So it's working fine. So there's no change. Thing to check. Okay. So fine. So now guys, let's see. So this is test system right now. Website is not there. Okay. So now let's start. So as soon as I post my code uploaded in the GitHub, now your job number 1 will wait for 1 minute because we schedule here for 1 minute, and there's no good thing, guys. That's what I have to resolve today. Okay, but they have to wait for 1 minute. Within 1 minute, they check. They keep on going every 1 minute, every 1 minute, every 1 minute, and as soon as they go to GitHub in the next 1 minute, okay, they can see something change in the code, or because they see something change in the code, they download the code and trigger the job automatically. Okay, that's what you will see. But here it's not yet started. 5 days. Why? Because I write a policy. The minimum time I can set here is started, right? So now it's going to build queue, right? So this build queue started. My job is running here, and the slave 1 running, not slave 2, because I allocate to slave 1. So they are running slave 1. Okay. And if the job was successful, then they triggered job 2. This was the test, and this test will run in the slave 2. Okay, so here the slave 2 test go in the queue, and from the queue they will move to slave 2. Fantastic, right? And they are running slave 2 where they are launching the container. As slave 2 was successful, so there is no further job. I write over here. By successful, my container launch as app. My team, in my internal team who is testing this code, okay, they can come to this URL, my test system URL, and see, and they can see website is working fantastic. See, everything is automated, right? And this computer is slave 2, and now this slave 2 computer is actually we are using for test team. Why? Because the test, right? And how the test? The one of the way to test the website is open the URL. If the URL open, I can see the website. That's what is test, right? So my test is successful. But here this test is kind of manual test. But if you to make it automate in a minute, I'll show you. Okay, but it's working fine. Okay, and here very quickly, if you go to test, they say last job I run, okay, by the upstream project, and I was run successfully by my upstream project. They are the one who launched me. Okay, they are the one who launched me, and I was successful. So that's so fantastic, right? Now in this setup, that what almost kind of what I explained in my last class, we have to do a lot of changes. First thing that I don't like about this setup is in the build part, that is running in the slave 1. Okay, this build part taking a lot of time actually. Okay, so 2 challenges we have even, I can say. First, when the developer upload right now, we never come to know when the developer upload. We have to go to Jenkins again and again. Okay, every 1 minute. Okay, and everyone where we are going, if we don't see any change, we are not doing anything. But if we see some change, then we start running the job. So there's 2 challenges here, especially in the trigger called Pol SCM. Okay. So right now we are using the Pol SCM as a trigger in job number 1 build, where they're going to GitHub. How? With Pol SCM every 1 minute. The 2 challenges we have. First, if your developer does not change for 10 days, still every minute you're going, so it's unwanted load in your job. and the job is running in slave node 1. So every minute you're going, obviously you're going every minute to checking. So it's extra load on the RAM and CPU and the network also. So somehow performance degrade. Okay, and even though let's say developer change right now, let's say the time is morning 10 o'clock, okay, and at 5 minute and let's say 10th 11th second they change. Okay, but your job never come to know the change, because the job will check every minute. So next minute 10 minute or 5 minute 59, then they move to 10 minute 6 minute. As they reach to 6 minute, but after almost 49 seconds they come to know something changed. Then they download, because they're going every minute. Then they run the job. It means you always see some delay, sometimes 10 seconds, sometimes 1 minute. Okay, but there's a delay always to run the job. So the two challenge in the policy, trigger. Okay, there's always delay, maybe not more than 1 minute, but it's always delay. A second big challenge is performance. Every minute they're going check, even though you're not changing for 10 days, still they're going every minute. Is unwanted extra network traffic or extra load on the performance. Hit, actually, I can say. Okay, so in this scenario, maybe in some scenario policy may be good, but in this scenario, using the policy does not make sense. So what we can do, so we can use some smart move. A smart move is, okay, we have a developer is one thing, we have a Git Hub is the next thing, and we have a Jenkins. Okay, here, okay, Jenkins because does not know when the thing is changing in the GitHub as a code, because Jenkins whenever the code change they will like to download. Because Jenkins does not know when the code change, that is a reason they keep on going every minute. So instead, what we can do something like this. Okay, GitHub is the one who know when the change occur. Okay, because GitHub is the one who is managing the code. Okay, so what we can do, we ask Jenkins now, Jenkins, you don't go to GitHub. Okay, as soon as developer upload, then GitHub come to know something change, code change. So GitHub will come to you and tell you, hey, something changed. Okay, then GitHub will tell you, rather you go there. And when GitHub tell you, then you can go to GitHub and download the things. There's no more sense, right? It means in this case, what happened? Okay, first benefit is if developer not changing for 10 days, you don't have to go again and again. Unwanted impact on the load. You save a lot of energy and time and performance impact also. Second benefit is as soon as the developer upload, GitHub come to know the change within a second or less than a second, GitHub will contact to you and say, hey, something changed on me, come and download. Same point in time, you can go and download and pull the things. So in this case, what happened? GitHub is the one who is triggering you. So GitHub is the one who will go and trigger you. Obviously, you means your job. Okay, will trigger you. Okay, and this concept, guys, is called GitHub webhook. Webhook means GitHub is like a website, web app, and they're hooking with you as a job. Okay, so this is called GitHub webhook. That make more sense in this example, right? So in this kind of scenario, what the scenario we built in the last class that I explain again, is good practice to use GitHub webhooks. Okay, and for this, what we have to do? So in this project, rather than I use, again, I'm going back to dashboard, so no confusion. In the first project, build first job. Okay, because they are the one who download the code from GitHub. How? Checking. But instead, I go and check every minute. I can change and say this one. That's all. Now, in this case, this project will automatically run. Okay, when something change in the GitHub, the GitHub has some polling. But who will run me? GitHub will come to me and trigger this job. It's called GitHub webhook triggers. That's what we have to enable. Okay. And after you enable this, save. Now this job, even though you can see guys, this new line also gonna come up. GitHub webhook logs. Right now is nothing because GitHub is not yet come. Okay. But now GitHub will come to you and run this. For example, last time the job was 9 times, but next time job will be job number code 10. And who will come? GitHub will come and run for you when something change. Okay, so let's see. If you just go to GitHub perspective, last time GitHub changed. Oh. So let me again, I am a developer. I'll go and change some of the code. Let's say change would be change number 6. Okay, this I'm setting my laptop. I will again commit it. And only after commit you can push the code. For my laptop, I'm a developer. My code is uploading to the GitHub. You can see the code uploaded here. Okay, yes, now with this comment. And because GitHub is the one who know code uploaded or changed. So now GitHub will go and contact to Jenkins and the job. I mean, job should be run automatically, right? So last time it was 9. Let me refresh. Sorry. It's not ready to run, right? Why is not running? Because I ask my job that you will be triggered by GitHub. Okay, but GitHub has no knowledge, guys. Jenkins is a different tool. GitHub is a different tool, different company, right? They should also know they have to do something, right? Okay, because GitHub is the one who is coming. Okay, so GitHub should know they should go and do some trigger on some Jenkins running somewhere. And where the Jenkins is, they should know the URL of the Jenkins, where the Jenkins is running. Okay, so in this case, what you have to do, some setting you have to do in GitHub also. So in the GitHub, okay, what we do, guys, we create a lot of repositories. Every repository is equals to one folder, one project. And for every project, normally in the Jenkins, we create a job. That's what we created here. So for this project, or this repository, we create a one job to do something. So what we can do in the GitHub, we can go to project level. Project means we go this to this project and say anything change in this project. What changed? So if you know, guys, Git and GitHub, I told you multiple times. I have shared the entire training of Git and GitHub. I highly recommend to complete this training because there are a lot of concepts in Git and GitHub to be understood. So when you know this, there are a lot of things we can do in Git and GitHub. One thing is, if you do any change in this GitHub, okay, how we are uploading something, so it's pushing. So my developer is pushing something, okay, pushing something, or we are deleting something, we are committing something, we are changing something, we are removing something, creating a new branch, whatever you know. So whatever you do in the GitHub as a project, everything is called event. Okay, even though when you change something by uploading, it's called push, this called push event. When I delete this file, it's called delete event. When I update this file, commit event. So everything you go do in the GitHub in this project, they understand something is happening, something changed, something event occur. So what we can do in the GitHub, we say GitHub, if something change occur in this, or I can say some event occur in this project. What kind of event? Let's say event is push event. Why? Because we know, okay, as a good practice, we don't change directly from this page. We can change also if you want to change in the code. But the good practice is normally in the GitHub, we don't change directly. Instead, my developer sitting in the laptop, they're doing changes, everything from there. and they are the one who going to do push. Any code change in this code to be done from push only. So push is the one who is changing the thing. Push is the event who is changing the thing. So I know whenever push event occur, it means something change. So if this event occur, then go and contact to Jenkins. Now where the Jenkins is, so I'll tell you the URL of the Jenkins. Okay. I'll tell you URL of Jenkins, just go and contact the Jenkins. And if Git is running in the public world, internet, so whatever URL you have to give to Jenkins, it should be a public available URL. So they can have a connectivity. Jenkins server, you should have public IP. In my case, chance. This is a public IP. Because I launch in AWS. AWS by default give a public IP to us. So that's a good thing. It means we're running in the Jenkins in lab give a private IP address. So work. Okay. Somehow you need to have public IP. So there's many more settings you can do at home and broadband connections. So there's a different port. You need a public somehow. Because you're not going. If you're going out, then you can use a private IP. But somebody coming in, so where the Jenkins is, so Jenkins system need a public IP. In my case, I have it. Okay. So GitHub will go and contact to Jenkins. How? Now this setting we have to do in the GitHub. So first you pick the project, which project or repository you want to do this integration. So technically we are doing GitHub to Jenkins integration. This is called GitHub hook trigger. So first go to projects, and in the project you have to go to settings. Okay, and in the settings, if you see in the left side, there's a tab called webhooks. Okay, and if you click on the webhooks, they say this will allow to connect external services to be notified when certain event happen. That's what I'm talking about. And in our case, external service Jenkins. Notify means they're asking to do something. Okay. And this webhook we have to create. And for this, you have to add the webhook. Okay. Here they're asking me some authentication code. I don't know where they send me. There's something in the change. So let me use the password of my hub. Yeah. So they say here, now tell me the URL of external service. In our case, okay, the URL is this one. Okay, so they're asking me give the URL. In our case, the URL of the Jenkins is this one. Okay, this is the URL we have to give. Okay, so this is not perfect. We have to do some changes here, but here what I'm doing, saying to the GitHub that in this project, there will be hundreds of projects maybe in the GitHub, but in this project, if some event occur, which event, that's what we can write here, which event, push event, or we can select one of the event. So if you know about Git and GitHub, we can create a branch, delete the branch, commit, change, a lot of things. So whenever anything changes, any of these, you can trigger something, or you can say any of the events, everything, anything happen, every time you just go and run the job. But most of the cases, we use a push event. So in this project of GitHub, when push occur, means somebody upload something, means change something. When this happen, then only, okay, you have to contact to this URL, and this URL is a Jenkins. Technically, you have to ask Jenkins to trigger. Okay, and I'm activating this trigger. Now, guys, there's one more thing I want to add here. Let's can you go give me 1 minute, please? Just 1 minute, please. I'll come back. So yeah. So technically, with any external platform in this called GitHub here, want to connect to Jenkins for every purpose, guys. In this kind of tool like Jenkins, we have a different URLs available. That's called APIs available. Also known as URLs available, right? What I mean by this, okay. My point is here, you don't have to type this URL. This is a different URL only to come to this project. Okay, for example, if you go to dashboard, we have different URL. If you go to this one, we have a different URL. Okay, so every purpose we have different URL. Similarly, if you GitHub will want to come to Jenkins to do a webhook trigger, so we have a different URL available. You can use the word URL, or you can also use the word that's called API. Okay, so what is this URL? We don't know. Maybe you can see in the document of the Jenkins, or you can search for Jenkins GitHub webhook. Okay, URL, something like this. You can just go and see some of the websites or the Jenkins official website. They'll tell you, okay, if GitHub only want to come to Jenkins for this concept what I explained to you, what is a URL we should use? Okay, so guys, here this is the URL they give you in some document, GitHub/webhook. Okay, so this is the URL to use. Okay, everything we have a different URL. So GitHub/webhook. Technically here, okay, we have to use a URL that over this IP port number. Then after this, GitHub/web. Okay, so maybe in some other site also to verify, but this is what they're talking about. Okay, Jenkins base URL/GitHub hyphen underscore webhook. That's what you have to write. Okay. Second thing is, if you're passing in information, because you're right now, what is happening? Your GitHub is passing the information to the Jenkins, and passing the information, you have to tell the content type how you want to pass the information in this way and this way. So that's what you can type here. So in the document where you find, they'll tell you. So when you're passing the information, what kind of content type you that support, how they can pass the information. So they also tell you somewhere that you're passing the information from GitHub to Jenkins. Okay, so that point in time, we support that type. Okay, so just go and read. They will tell you I have to send the content in form or JSON format. Okay, so let me use the form encoded format. Okay, so this is one point. So it is something like this. If you guys create any website, okay, and in the website, when you fill the form, let's say facebook.com. So this is a form you have, right? So when you fill the form, you're passing the information to website. So this way of passing the information from your system to other server, that is called URL form encoded. Okay. Or sometime when one service want to send the information to other service, the way they pass the information, they use JSON. It's just a way to tell how we are passing the information. Okay. So here GitHub will pass the information to Jenkins. If Jenkins does not support JSON way, so it will fail. Okay, if they support the send the data in a form way, this called URL encoded, they need to pass in this way. That's the core concept. So GitHub say I can pass the information to you in both the different way, though the format, JSON format and normal form encoded format. Okay. What you support, I can send in this way. So here you have to ask the Jenkins document Okay, and ask to document, hey Jenkins, I'm passing the information GitHub to you. What you support? So in some of the official document over here, also you can see they say, hey, I support JSON. So if Jenkins support JSON, then you have to send in JSON. But if you use other tools, with GitHub, if they support some other format to send the data over the network or internet, that content type you have to use. So there's a core idea. But this is guys how you integrate. Okay. So this is URL I type. This is Jenkins URL. This is the what Jenkins give me the URL name or the API name. Okay. API name. And Jenkins say I only support JSON. So you are the GitHub, you send me in JSON format. But when GitHub contact Jenkins, when this event occur. That's all guys. And let me add the webhook. Okay. So this webhook has been added. And to check it is working fine or not, you can see they actually internally they test automatically. They test automatically just to quick check. And look like something is failing. So if I click here, and there's a button here, the row is not there, but now this button gonna come up. They say, I am a GitHub, I try to contact to Jenkins. Okay, but it failed. Okay, why it failed? You click here, they say, I try to contact to Jenkins to this URL, send the content this way. Okay, and some kind of error they give me as a response. Okay, and they give me some response. Okay, so this response they say look like a failure. Let me try one more time. Just to try to check the connectivity. Again they are sending. Again this time look like it failed. Now there will be a lot of reason guys why they are failing. One of the reason is one of the reason is sometime is whenever you type the URL and the URL should be end with slash. Okay, where slash is the one meaning in APIs and the URL. Okay, so this is one of the reason can be. Let me update this. Okay, and let me check one more time. And retry. I'm just testing from here. Okay, testing from here. Let me redeliver. Yeah, fantastic, right? This was the challenge, right? So those who know a little bit about web development, slash has a different meaning altogether. Okay, so if you don't write slash, that thing is a file name. If you write slash, that thing is a folder name. Then we go inside the folder and they look for some other byte for page. So it's something like this. But it was successful. Okay, it means my webhook has GitHub has been integrated with the Jenkins. Okay, that was the message shows. One point, and second point is even though you can see the output response from the Jenkins. So I'm a GitHub. Jenkins say 200 means successfully connected. There's one point. Other challenge if you're not able to connect is spelling mistake. Third reason is your IP is private. So GitHub, you can want to connect to Jenkins, you need a public IP. And other reason may be this port number block in firewall. So whichever firewall you are using, maybe AWS Cloud and something like this, you should have proper firewall enabled. Okay, these are the few reasons why it won't work. But in my case, it's working fantastically fine and then integrated. Okay, and if you go to Jenkins, okay, see here some job they run right now because I was keep on testing there, so they run the job. But if you see there's job 13, okay, it is run by SCM. Okay, but let me show this demo one more time. No, sorry, not this one. Was wrong. So this is what I'm trying. So till 9 because they're testing because yet not there's no change, so they won't run. They only test. But like again, if you see this last job was 9, Now what you will see, everything is automated. Last time it was also automated, but in this case now, my build job won't go to GitHub every minute. They only enabled this part and say, I will only run if GitHub come to me. If the GitHub not coming to me for 10 days, I won't run. So it will save a lot of energy, time. Okay. And as the GitHub come, they will run at the same point in time. So they run very, very quickly. So right now my job is running 9th time. See the ID of the job. Now what I'm going to do here. So go back to this project again. So I'm into this project. Same project. This project changed 21 minutes ago. Now my developer again sitting in the laptop. Okay, let's say they change 7. Let me change the color to green. So small changes. They do some commit again with same name, does not matter as a push. Now this time you will see, guys, as soon as I push, your job will start automatically. You don't have to wait. I push, it will go to GitHub, and as they go to GitHub come to us here, fantastic, right? Quickly. That's what the speed is, right? Automatically. Okay, so as they got it to GitHub change the time, and as soon as the GitHub change the time, okay, now they internally contact to Jenkins, same point in time, you can see the running. Okay, and if my code is not changing for 10 days, Jenkins is not going to GitHub and nothing is going. That's what we want, right? So it's a great trigger actually. And if you see the 10th, and they say my job is run by GitHub, they push me. So GitHub is the one who coming to me. I'm not going there to pull, download. GitHub is pushing me to run this job, automatic trigger. This is called Git webhook. That's what they are talking about. Okay, and if you can see the polling logs, okay, you can see this is what you can see what they post and all the things about the GitHub perspective. And if you say GitHub web hook logs, see it was not there, right? Last time it's coming, right? At this point in time, GitHub start event to this URL, okay, and they launch the job. Okay, remote job they launch. That's what you can see from here. Everything will be run automatically. So finally, my testing team, this is the testing system, slave 2. Okay, they can see some new change in the website. It's not updated here. Why not? It should be, right? Other thing is connected, right? So 10th job is running. That was successful. So what they do, they create a Docker image, they pull, they launch this test job. That's also they done, right? In the test job, okay, they also run the job over here, and in this job, okay, 10th job of my build, run this guy, and they launch the new container. And if they launch the new container, then it should show you the new website. Why is it not coming? It should come, right? I missed something. This one should come, right? Let me do a small change again. Let me see. 8. Or sometimes you have a normal caches, guys. Let me open this thing in the command line. Let me check with the curl command. It's also client-led command. No, it's not changed. Why not? It should be. Let me change. I'm going to give a new commit ID. Something ID commit ID might be a challenge. So now they are running the job. My test job run second time. Now they're going to run soon automatically. So they should run the third job because my build job was running automatically 11 the time. So they run 11 time. So my test job, yeah, they started automatically. Okay, they was successful. Okay, and who run this build job, and the build number, the ID number 11 was the one who launched this. Console output is fantastic. They remove the container and launch a new container. Okay, so your output should be it's not coming, right? Why not coming? Okay, it's not coming. One minute. It can be issue in the image actually. In the image, they are not taking the new image. Let me go to my Docker Hub. So image actually uploaded in my Docker Hub that I showed you in my last class. Let me sign in to my Docker Hub. So this was the image I uploading. Okay. And if you see a minute ago, I upload this image. Okay. So what is challenge? Why they're not showing me the latest content? Let me see the Docker file. We are copying the same content also. Okay. So then what is the challenge? You're working fine, right? Last class and today also I show you. We have to check on the node slave 2. Okay. And how can check? Slave 2 is a guy's computer where my container is running. So I run the Docker PS. So 2 minutes ago, they launched this container. It means job 2 runs successfully. But here they are using an image. I think this image may be the reason. It's not getting a lot of content. So how can I check? I can log into this container to check in this container called my OS1. Okay. And get the bash shell. So I'm inside this container from this image. And here, if I see the content of index.html, okay, this is the issue, guys. They're not copying the content. Okay. So image is not perfectly created actually. So my test node is working great. It is the challenge from the build node. They are not building the new image. Okay. Even though they are showing in the build, the job was successful. They downloading the code, the building the image, the copying the content. Okay, in this location, and they changing and pushing the image push is also uploaded. Okay, so what is challenge then? Let me go to my build system. It is not again the issue of the Jenkins side. It's just some issue from in the build step. Let me figure out, then we can move to next part very quickly. So technically, you know what happened? They download the content here in my Jenkins namespace that I show you in my last class. So here they downloaded the content Docker to build. This code downloaded, guys, from the GitHub, and in the GitHub, the content was coming from GitHub perfectly fine. So we uploaded successfully in GitHub. Content is perfectly downloaded here. So this is not the challenge. Docker file look like also good. It's not challenge. They build it, and after build, they create a local copy here. Let me check. Sudo. So right now the local copy also created here 5 minutes ago. Okay. 5 minutes ago and we rename it. Let me check this they create the right copy or not. So let me run the locally this container LW web v1. Okay, and just giving some name OS 111. Okay, I'm just checking locally with Docker command. Okay, so if I go inside this OS that I run locally, okay, and if I go here, okay, and the content, again they're coming fine, right? It means the challenge in uploading actually. So finally, what we conclude, we create an image successfully here locally. Okay, it means there's challenge in the uploading, guys. Only in the uploading part. It means my Docker info if I run the command. Okay, and Docker info. Let me run the sudo. Okay, this command normally show you that you have login successfully to the Docker hub, but it is not any kind of visibility here. It means after format, you create this image, okay, and try to upload. Uploading is not happening. So it means if you run the Docker push command and try to upload in Vimel 13 account with LW web v1, it was failing. Okay. It was failing. It's not failing. Format Docker IO. It's working fine, right? What is the challenge then? Okay, one more last check I like to do here is let me do Docker dit one more container. Let me launch name OS 1. Let me go to OS 1. This is unwanted thing. Let's check so that you can see here, right? Uploading is also happening perfectly fine. So what is challenge, guys? I able to see any challenge here? Uh, are you able to see any challenge here? Let me push again without sudo. Obviously, sudo does not work with the Docker. We have to use sudo obviously. Yes. Okay. Uh, I don't know. Last guys were working fine, right? Even though they said the push successful, right? So there is no error in pushing. Okay, there is no error in pushing. Error is, the error is here. Okay, error is here in our test project actually. Error is, okay, we are deleting the container. We are not downloading the image every time. Okay, in the test computer, okay, they're using the image from local computer. And this image they initially downloaded already of last version. Okay, so they initially downloaded, so they are not downloading again. In the Docker Hub, the image is being changed by local computer, worker node 2. This is worker node 2, I believe. Okay, if you run the Docker images, sudo command node there, sorry. So if you run the Docker images in the worker node, they downloaded image long back. So today I started, they download that point in time. So they're not again downloading this image. And this is the older image, right? So what we have to do? Okay, what we have to do here in the in this guy, okay, we have to remove the OS and asking this guy to download this image again. Okay, how? This is something like this. If you want to download the same image, what do you do? Pull. Then give the image name LW Web V1. So again, we download, and you guys know in the Docker world, the good thing is every time download, you don't have to download all the things. They only download the changes part, whatever the thing has been changed. Okay, so new changes they will download. Okay, and they also say new changes happened 11 minutes ago. So pull is not the command that will create an impact. They only download if something change, or that only that part they download. That's called delta part or change part. So we can run this command again and again multiple times. There is no extra overhead for this. So this is the missing part in our sequence. Okay, and let me see. Okay, so yeah, this is how you mature your platform, right? Every time you face the issue, update, troubleshoot the way I troubleshoot by chance here. And let me do one more change here, 9th time. Okay, I am a developer. I commit, I push. Okay, now both the jobs and run one by one as a sequence. So right now the job is running in a sequence. First job run, then second job run. That's what we want, right? So both the jobs are running one after another as a sequence. And when the job number second run, then your project to be deployed in one of the computer. That computer is slave 2, and slave 2 I'm using as a test computer. Test computer. And slave 1 I'm using as a as a build computer. So anyone who is a testing team for my company, they say, whenever I test something, I will go here, download the image, run here, and after run, we as a human being, we go manually here, open the browser, hit enter. If site opens successfully, that means whatever we have done is successful. It means test has been checked. Okay, but I guys here everything working fantastically fine. But if you want to make this test automatic, that you don't have to check by ourselves, then a lot of things we can do in the test part. Again, this is not the class for test, how to write a test cases, but one of the small test case you can write. Okay, because rather than I don't want to test this part manually, I want this test to be done automatically. So whatever you're doing here manually, you can do from command line. For example, let me open my command line and say, command line, can you do one thing? Can you curl this website? Okay. And when you curl this website, if you send some output, okay, there's a lot of extra output coming from curl download. So you can say silent. Silent. So if you see some output, okay, if you see some output, okay, and if output is there, it means your website is connected successfully. Okay, connected successfully. Or maybe in this output, let's say in this website, every time you have a welcome as a text message. So you can also write pipe grep command. And when you see a welcome as a message somewhere, okay, it means site is accessible. That is the reason you can see welcome. But if you write a wrong IP address, IP is not working, let's say, you won't see any welcome message. Okay. If you won't see any welcome message, obviously, it means either site is not up, the main text is not there, site is not connectivity. Okay. And site is down, deployment is not done. content not run, with many more challenges. You can see there's no output gonna come up. Very small example it is. It could be very, very complex, advanced uh, uh, command you can write, or a script you can write, or if somebody we have in a company, we can write a lot of advanced test cases. So this is not a training for test cases writing, but it's a very simple test case where I don't have to go manually and check, set it up with the message welcome gonna come up by chance. Instead, we run this script, and if this case runs successfully, you can see some output. It means working fine. And you guys might know one more small thing by chance if you know. This is the command line tool, guys. And this command we're running in the shell. And good thing is, whenever run any command in the shell, with our date command, if the command runs successfully, then behind the scene, this command will send a code. This called success code, also known as exit code. And this exit code is stored in one special variable called question mark. If you can print this variable with echo command, so echo is a command to print, dollar symbol to tell the variable, and question mark is a variable that store your exit code or the success code. If the code is 0, it means last command runs successfully. If I write last command wrong, this command says something else. 0 means successful. Anything come apart from 0, it's fail. Okay, it means if I run this command, okay, if this command is successful, then you can see the exit code 0. But if this command is fail, let's say I say, so this is not working. So because it's not working, there's no connectivity. So the command will show you nothing, or maybe some error, maybe sometime. Okay, but exit code will tell you it pass or success. So why is it important, guys? Right now, I'm just showing you a very small test case to write. Even though it's not part of this program, but you should know it. We can make it very, very interesting thing. If you add the exit code, you can see something else come up, right? So anything apart from 0 gonna come up, that is called failure. So what we can do here, we can add a small script. So guys, this is called shell actually. And the shell, guys, there's a concept called if condition we can write. And the square bracket will say, if this symbol is equals to 0, if this is the case, then I can say, okay, means successful. Else, I can say not okay. Again, the shell scripting to close the if, we write if I reverse. Now this is a shell. In the shell, we can write also a script that's called shell scripting. And shell scripting, we have to start a block of if with then. Okay. And after else means if the condition, there's actually condition. If the condition is true, they run this block. If the condition is false, they run this block. And to close everything, we write fi. If last command was successful, so they say, okay, let me show you one more time. Date is successful. When you run this code, it's okay. If you run the date 1 is fail, they say not okay. Last command was not okay. Okay, that's what we can do. Now, what we can do here is same logic we can apply, because I know my test system IP is this one. Okay, so I take this command, go to my test project, and the step I say after you deploy something, go and curl this website. I want to see this website on port number 80. This is the port number they're running on the IP of my slave node, and I know the slave node IP. Okay, they go and curl. If they curl, means they access and get the welcome message. It means site is up, content launch. We have no network connectivity issue, and we have also content welcome or whatever I'm looking for. But how I know I have this curl or not? Because if you see manually, you can see the output as a human being, right? But if you want, your program can see the output. So for this, we can check if this command runs successful. Okay. If this is the case, then check this. Okay. So when this command run, they give you the output behind the scene. The output stored in this special variable. This is called exit code or status code. If it is 0, then run echo okay. Else run not okay. That's it. Okay. That's what it will tell you. One more thing we can do here is whenever you run a job, let me go one more page. I want to show you one more interesting thing. Whenever you create any job in the Jenkins, let's say a job 1 in Jenkins, one more interesting thing you can do in the job is if you want to tell your job fail, so manually you can do one thing. You can run a command, exit command. Exit is a cell command actually. Cell command. If you exit, the program close. Okay. But while doing close, you can pass some number. 0 is a number that means this program close or this job close with 0. 0 is a special number that means successfully close. It means when I run this job, you can see your job will run successfully. Here, green tick. Why green tick? Because we close this program and the status message I pass is 0. That means successful. But same job, there's no technical error. By if I run the job with exit 1 or any other number apart from 1, apart from 0, sorry. Okay, technically we're passing this message to this job. Everything is good, but still you have to send everyone a message is failed. See here, failed, right? Red color. And why failed? Because my job intensely I send and say send 1 means failed. Because when you run a job, and in the job, if you're running shell as one of the way to run, and if you pass 0, it means successful. If you pass 1, it means you're intensely sending a message that I'm failed. Same concept you can apply here. If you curl, then this is true. Okay. In this case, you can send exit to close this program with 0 message to tell I'm successful. If you're not curl, then this is false. You can go to else and send a message with exit 1 to tell this job is failed. The job is not stable. So this is one of the block of code and this is one of the block of code. Okay. So this is more script, guys. Again, this is not shell scripting class. Those who know shell scripting, or those who want to learn shell scripting, you can, there's one training we have in Linux where we can go and learn very detailed shell scripting there. Or otherwise, you can ask your shell scripting guys, they write this script for you, you can go and copy paste. Okay, but this makes more sense. Now, in this case, okay, if you're running a job, they will test for you. So what I did, rather than I test by myself, always, I belong to test team, I'll go and open the UI and see it working fine or not. Instead, my same job will test. Okay, test, and they will only show the green color only after the content launch and they have a network connectivity, something like this. Okay, so I write some kind of automated test here. Okay, so let me change something in code. 10. By chance, I'm testing only for the welcome as a text string gonna come up. By chance, it is here. Okay, so I commit and I pushing everything now. Everything is automated here. Okay, GitHub is coming to Jenkins automatically, running job 1 build automatically, pushing in get Docker Hub automatically, download from Docker Hub automatically, running this second job automatically. in the test environment or test server, and testing also happening automatically. Okay, so we will see in a minute the fourth job gonna run. See here, they start running fifth job, and after they run, they also test. Okay, and only the URL accessible, and obviously URL accessible only when you have proper network connectivity plus container launch. It means everything you're checking in one go. Okay, and we're also seeing some checking some content also. Content is um, welcome, or we can see some other content, maybe whatever you want to check, and then only your job will run. So still they are running. Let me check why they're taking a lot of time. Okay, so they are running here, and guys, here it will look like a hang up. Look like a hang up. Why? Okay, why the hang up here? Why the hang up here? Okay, so one reason I told you in my last class. Okay, whenever you want to run, any command like this, okay, or maybe this they are hang up because of this reason also. I write a wrong IP. Maybe this is one of the reason. Okay, so my IP of my slave system is wrong, is 75. That's also, it's good thing we tested actually. We tested actually. So they show you guys in a minute, they fail. So they're trying, connecting. After some multiple try, their says will fail. So the good thing we tested, right? My good thing is my this program is testing, and finally sometime they show you fail. So my test is working fine. That's the good thing. Okay, but sometime when you write a script, okay, let me first update the IP address first of all. 5. Okay, and second thing, whenever you write any pipe, this kind of symbol. Okay, I told you in my last class also. This is kind of cell special symbols. And this symbol, guys, if you want to run behind kind of symbol directly in the command line by manually, the way I show to you where it is. Let me show from here. 1 minute. So if you run this symbol directly manually, this pipe symbol and greater than symbol, it won't face any issue. But if this kind of symbol is called cell symbol, if you run by some other program behind the scene, like with SSH or Jenkins, sometimes they won't work. Okay. So what you can do, you can run this as a complete string and run with ss command as a command. Okay. Then they won't create any big challenges. So that's what I would like to use here. Okay. So two things, this one, and plus I changed the IP address. That was wrong. And let me save. And large of fail, guys. That's nice, right? My job runs successful. Last time, guys, maybe they're unsuccessful, but because they does not able to connect, because maybe Docker was wrong, IP was wrong, something happened, so they fail. The good thing, right? Because of my test cases, my job run fail. It means before I move to next step, to launching in the production is very critical. My test case tell me, okay, I am the second job. I will only trigger third job. This is a production one, only if I'm stable. But here they say I'm not stable, so they are not launching in the production environment. That's a good thing, right? Okay, good thing. But let me do again one more time. I update my something here. I again change in my code. Let's say 11 change. Again, commit. Don't forget to commit. Commit is the one to update what you change locally into the local database of the GitHub, and whatever local database you update with a commit, this is called commit area. That is the data upload to the GitHub. Okay. Now, same thing happen. Build process going on. Sometimes it says sixth number ID of the job run is called job IDs, and that will run over here. Now this part will run. Now next, so we write one small test case also. So now this starts 6, and sometime you can see it will work fantastically fine. It should work. Otherwise, we'll change some in the script. So this part is done, guys. Now let's move to the third step, guys. Is the deployment stage. So what I want as second step done completely, then I want third step to be run. Okay. And for third step, I need what they do, the deployment. And for deployment, what I need here, I need one more computer actually. So for this, I need one more computer as a slave 3. Okay, why one computer? Because for deployment, we need a different set of tools and commands. Okay, here we have a git command, docker login. Here we only need docker command. Or maybe here I write some test scripts, so I need test related some kind of utility. I don't need because I write very small test case. So we need that kind of command. Okay, but to deployment, depend where you deployment, you need those utilities here or those commands here. So that is one of the reasons why I need a third computer. So because in my case, I want to deploy, I told you already in the Kubernetes. So Kubernetes has been created by somebody else, but to connect to Kubernetes, you need some kind of tools here or commands here. In my case, kubectl. That's what you need. Okay, so for this, I need slave 3 computer. And it's also very critical because it's not only about kubectl. Okay, here you need two things. You need kubectl as a command, as a client tool for Kubernetes. Plus, you also need some password here. So kubectl will use this password to log into this guy. So that is also one of the case. This system very sensitive. So I need one separate system for this, a separate slave system for this. So again, still the fail. Why is fail? Let me check. So they launch the OS and they run this command. So I guess they run one command as one go. But when they run this command, they say it's failed. Why failed? It should work. Let me check this IP address. IP is work. They change 11th. This command is not working. Okay. Wow, what is challenge? In the script, I don't see any challenge here. The grep. Okay. 1 minute. So they run this command. Last command, I take the exit code. Okay. And print it. Let me do one small change just to quick check. Let me see the output of this variable. What is the variable they're taking? Okay. And let me also remove welcome just to make it this command it's simple. Okay. And save. And let me run directly from here to quick check rather than we go for the entire process. Okay. They fail again. They fail again because of this command. Let me do again check. Maybe try to remove this. Let it assets. Let me directly use this. Again, they fail. Why are they failing? This command. Okay. I feel the reason is because we are running this command of slave 2. If slave 2 does not have a curl command, obviously they fail, right? But obvious. This can be one reason, right? I go to my slave 2. Okay. So with slave 2, I don't know, maybe this one or this one. Let me go and check. My slave 2 having this IP address, private IP. That's what it is. And the slave 2, do we have a curl command? No. No, yes, we have actually. We have, right? So let me run this command manually here to see. It's working here, right? And even though let me try with the welcome. Working here, right? What is challenge? If I see the echo, also getting this. I don't know why is that not running inside the Jenkins here. Let me try one more way. One more way. Let me remove this part just for a minute. Okay, it should work actually. I don't see any difficulties. Sudo actually we don't need to use. Curl does not require any sudo power. That's what I'm going to do. So much critical. Still they are not running. Why not running? What is the challenge here? Execute cell mark build as a failure. See any mistake? Let me at least try with sudo. Mira with sudo this part. This part also. This is working. I don't think so. Logically, we don't need actually sudo, even though they're asking here. So now it is successful. Let's use the sudo if you're asking to use. Logically, curl command is a client command we can use from non-root power also. Okay, so let's say use this because we don't want to invest the further time. We can somehow find also without sudo also. It will do some more extra effort, but let me use the same way. Grab welcome. Okay, so the same concept I explained in my last class, and let what I write already. If this is equals to 0, good thing, it is exit. 0 successful, else exit with 1. I think everything is right, syntax right. So this will exit same thing. So let me run this. Oh, it is working and they're successful because we have tested everything good. And guys, why we not sudo? Because we are not using Docker command here. Docker we use here, they use sudo, right? Here we are using only curl command, right? So curl command does not sudo. I don't know why they're asking. Okay, to use a sudo, but let's say technique is working here. Okay, so now it's working fine, and they're tested, and fun thing is working fine. So my second job is running fine. And because they're running fine, so I can say if second job runs fine, then they contribute third job. And for the third job, what I'm going to do, okay, I'll go and add one more node. And for the node, I need a node. So let me launch one node very quickly here. Some of the cloud where I want to launch. Let's say this is slave Number two, this is for deployment purpose to production. Okay, in the Kubernetes, there's the plan. Again, I'm using Amazon Linux, and let me use 2 GB RAM, or maybe this one. Okay, 1 GB also enough, but let me use a 4 GB, 2 GB RAM, so it won't impact quick here. And let me use this key to log in. Why I told you, because we have to connect to Node, so we have to use the key what I use to log into the system, the Jenkins, right? And anything else? No, let me give some space. That's what the challenge was coming in the last class. So let me give 20 GB space to the root volume, and 1 instance is enough. So one more new node has been launched, guys. Okay. And challenge here is in my account, we have a lot of computers I launched, so they have some limit actually in this OS. So let me delete some of the computer that I don't want to use. Okay. So next go is I explained to you already. Okay. And so for this, let's waiting for this guy to be complete a minute. But for this, I need a Kubernetes. So I have a Kubernetes setup, guys, already. Master and slave. Okay, that's the setup. I only thing what I'm going to do here is let me log into my Kubernetes master, check everything working fine. By the meantime, they delete. And how to log into Kubernetes master? Okay, I can use SSH client to log in. Okay, so to check my Kubernetes master system is working fine or not, and I have one key already downloaded. So this is the Kubernetes master. Let me log into this guy, and you can use kubectl command to check how many worker node in the Kubernetes we have. We have some 4 or 5 nodes, the 4 nodes. So this command tell that Kubernetes is working fine. That's nice. So those who don't know Kubernetes, you can understand, just take as a very quick information here, and my team will share the videos to you, so you can learn some extra new things. So this is a Kubernetes master node, and we have total 4 node. One is a master node and 3 worker node. So we have a 4 node cluster we have. And if you want to launch any container in Kubernetes, so pods. So right now you can see there's some pod already running from my last classes. But my plan is to launch one more new pod from the Jenkins. Okay, so for this, what I'm going to do, I'm going to clean everything here. Okay, all the setup what I had already, so I can show you something new. Okay, so like a new clean Kubernetes setup we have that I'm going to show you how to integrate Kubernetes with the Jenkins. Okay, so Kubernetes is there. Okay, but who will contact Kubernetes? Right now, I'm contacting to Kubernetes directly from the master node, and normally we don't give a master node access directly. So what I'll do, I will create one slave node for the Jenkins, but that slave node will be a client for the Kubernetes or the user of the Kubernetes or admin of the Kubernetes. Okay. So for this, I'm going to launch a new computer here. Okay. So this is a Jenkins slave 3. Okay. Kubernetes, for example. Amazon Linux, T2, let's say small. Key pair is this one, the same almost demo, what you see in multi-slave setup. And let's say hard disk is 20 GB. Okay. So now this is a new computer. I would like to use this computer as a slave node. And you guys know the slave node, there's a prerequisite. All right. One, you need a Java in the slave computer. Okay. So this is one thing we need. So in the slave computer, I log in and install the Java as a software. Okay. And after you install Java, then we can connect this guy and make the slave a part of master. And how they connect with SSH. And normally SSH is enabled mostly in Linux system. So we don't need to do anything for this. So let me connect to this system. And this system I can connect from here directly because it's Imagine Linux. Imagine Linux can be connected directly from the browser. Okay. So I am going to install Java here. So in Java 21, that should supported here. So this is Java. And how to make this guy as a slave, you guys know. To making the slave, you to go to Jenkins master node, add a new node. This is slave number 3. I'm making as a permanent slave. Okay. And this setting is almost same what I have in slave 1 and 2. So let me copy all the setting from slave 1. So I didn't have to do the same thing again. Everything same. Okay. But we also create one folder in the slave computer. Okay. Paste this folder. This folder will be workspace for the slave. The second, 2 things we need always in the slave system to be done. Okay. And this system, I'm going to use a name called my Kubernetes, his label name, or maybe my production, whatever label name you want to give. Naming same. Only the IP is changed here. So this slave is having the IP address called public IP. Is this one. Other user same is it to okay, and the key same what I created in my last class. So everything is same. That I explained to you, and I can click save, and slave 3 is working. They trying to connect, but it is not working. Okay. SS logging successfully. They can detect the Java also, but something is not working. They're transferring some agent file, it's not working. Why? Because in this system, okay, AWS has some kind of firewall that I didn't disable today. So select the system, go to security in AWS, this security group, and enable the security. Okay. So what I'm doing, I'm just going to allow all the traffic, so there's no challenge in the terms of security from all IP address. Okay. That was challenge only, I believe. So it was failing. Okay. So I go to slave 3 again. Let me launch the agent. One minute. Let me launch the agent. So they detect 21. That's nice. They're trying to copy the agent. What is challenge? Login is right. 1 minute, guys. So what is the challenge? It should work, right? So we are transferring the file to this folder. Challenge, guys, is actually it is a challenge related to Linux permission. Actually, the challenge is I create this folder from the root account. And any folder you create in the root account, that folder has a different permission altogether, guys. Okay, so this folder has been owned by a root account, and other user have no power. And in our case system from Jenkins, I'm login from EC2 user. That you have no power actually, and they're not the owner. So technically, what I'm going to do here, I want to remove this folder manually. Okay, manually. Okay, and log out from here, and I'm directly creating this folder from the EC2 user. So it's a related to Linux permissions actually. Those who know Linux, they know understand this what I'm talking about. So if you do so, same folder created, but here the permissions is this one. So this user on this folder, and this is a user where Jenkins is logging to this machine. So they log in with this user. Because log in with this user, so this user should have power in this folder. So that was a challenge actually coming. Last time I created it directly here, so it was working fine. So this is the only challenge. Now, if you see here, let me launch again. Now this time, guys, they're unsuccessful. I say they copy the data successfully because they permissions and they are live. Fantastic. So node 3 is also live. Now we have 3 node running. Okay, that is nice. So now what is the use of this node? In this node, we are going to run this command. And this command will go and log into Kubernetes and do something. So in this slave node, you need only 2 things. One, the command, and one, the password. And how to get the command? So this is the node you have. Okay, this node you have. Your slave node. Okay, as yum can give this command to you. The yum, no, they don't have. Because there's a client tool of the Kubernetes, and this command normally, guys, find in the market as it is. So what I can do, I can close. Let me search here. I say kubectl install for Linux. Okay, and here you can find some link where you can download this command. It's a client command for Linux. I am looking for the Linux. They give me one link. So copy this command, that's all. And paste here. Okay. Paste, and this command I'm gonna come up here. I downloaded this command. And this command is actually a program. So you have to make this program executable to use plus X. Okay. Then now we can able to run this command. And because the command is the same folder, I can add /kubectl. Now again, this command is running fantastically fine. So these are some basic steps of Linux you can download from some website, make executable, and because this program is not there in some of the paths, so you have to write / to tell this is located here. Or better practice always to copy this thing in the some folder where all the command located. So better practice, I can copy or maybe move this command in some of the folder. Let's say USR bin is one of the locations where you normally put all the commands. And to copy something there, you need a sudo power or root power. Okay. So my command will copy in some of the path. Now we can run this command from anywhere, does not matter. We can run fantastically fine. So finally, we have this command copied. Okay. Now with the help of this command, okay, you can now contact to Kubernetes cluster. So I'm sitting here, guys, and this is an independent computer working as a slave node of Jenkins, but now also going to work as a user, the client or the admin of the Kubernetes. So they need two things. One is kubectl command that I have. But still, if you try to run and try to contact Kubernetes, say, show me all the nodes, it won't working. They say, I don't know where Kubernetes is. Because this command should know, okay, where the Kubernetes cluster is. So they should know the IP address, they should know the password. And in the Kubernetes world, all the information, that is IP address and the password, they store in one file called config file. And those config file your master node will give to you. So in my case, the master node of Kubernetes is this one. Okay. And in the master node, in this particular folder, this is the very critical file. Okay. What this file contain? This file contain the information about Kubernetes master, cluster, IP address, plus the password also. So one file contain all the information. Okay. So here they maintain where the IP address of the server. Okay. What is user of the server? What is the password of the server? Everything this file contain. Okay. So typically, if you want to be a admin of the Kubernetes server, you have to give this file to those guys. Okay. So right now, I would like to give this file to this computer. How we can transfer, you can copy paste whatever you. Okay. So what I'm going to do, I'm going to transfer this file to this computer, and this computer having the IP address, this one. So how to transfer SCP and say I'm going to transfer this file to this guy. Okay. Where, let's say in some of the folder, let's say in temp folder somewhere, or maybe let's say in etc folder, I'm putting somewhere. Okay. Which file? This file. So you can transfer mail, copy paste, whatever way would be. SCP is the simplest way to transfer the file from your computer. I'm the Kubernetes information. I'm transferring this file to this computer. Okay. This computer would be Jenkins slave node 3 or Kubernetes client to this one of the folder. Yes. Actually is disabled, so I can't transfer. Okay. So what can you do? You can log in with EC2 user, but for you need a
Recording in progress.
So the key is you laptop, type on this file, copy this key, go to this computer, okay, and let me save here my dot key something and paste. That's all. So this is a file. We have a private key for SSH for this user. So I'm saying SAP to log in, take this key from this file. Okay. So log into this user to this IP address, transfer this file to this folder, and you need a private key. This is the private key you have. And this is a very small kind of warning you guys might know. Any key that is to open means this key is being readable by other users, so it's not secure. So I have to change the permission, otherwise they won't allow. CS mode is a command, and say 600 means this file is not read by other user. So that these are the pure Linux command, neither Kubernetes, neither Jenkins. Okay, and that is sometimes having basic knowledge of Linux always helpful. I am into Kubernetes master. I am the one who have the file. This file I'm transferring there, so we can copy paste also. I'm just using this command to transfer. Let's say in one of the folder. Let's say home EC2 user. I'm sending to their home directory and this file transfer. So that's all, guys. This duty is done. Now if I go to this system, you can see this file was not there, now come up. And who is this system? This system is the slave free. And because this system is the slave, and this system has a kubectl command, so they have this command also, they have this file also. Now, whenever they want to run any Kubernetes command, it is failing. But I can do one thing. I can give this information from this file. And say, when you want to run any command, take this file. This file has an IP address, details, password of the Kubernetes cluster. And guys, taking this file is known as kubeconfig file. So this option need to pass. So yeah, fantastic, working fine, right? Fantastic, right? Working fine. Okay, so I am a client of the Kubernetes now, or the user or admin of Kubernetes. Cluster running somewhere else in the world, I don't know, but this file know everything, the details and the password. Okay, it means if you want to run any command of the Kubernetes, okay, add in this thing the last. Now, what command run? I want to deploy something. Do the deployment from the Jenkins. So again, let's come to the Jenkins. Okay, and Jenkins, two jobs we already had. Let me create one more job. Okay, and this job is to production. Okay, to production. And this job, first of all, I'm going to run only in, that's important, my Kubernetes system, because this system who have the kube and they have the kubeconfig file, the client file, they know the password of the Kubernetes cluster. Is one thing I would like to write here. It's very critical. Second thing is I want this project run automatically after my Docker test project run. Okay, so they will run automatically. So after test project runs successfully, that's what I had, the test cases also there. If they run successfully, only then this project will run or this job will run. Okay, and what this job will do, they run a command. Which command? This command. So they run this command. Copy. Where am I? Jenkins? Here it is. This command. Over here. Okay, that's what they do. Okay, and we don't need to use sudo here because Jenkins behind the scene run the command to the node to EC2 user only. Okay, one minute. To this user only, and this user is the one, right, who have this file, who have the workspace also, and this user have power to run the command with sudo. Only thing is, you tell the path where this file located. So this file is located over here. So you have to give the entire path where this file located. Okay, that's it. Let me check till here everything is working fine or not. So I'm doing the check manually here. This command running or not, this job is running or not. Okay, so they're doing something. What they're doing? They are going to slave 3. Slave 3 is offline. What the challenge? Manage Jenkins. So if I go to node 3, slave 3 is offline, guys. I think because of the RAM issue, actually. That's what I was trying to give a bigger RAM. It is not because of RAM, actually. In the slave 3, I think I've given a very less storage. Come on, this is the big challenge. So what to do? Nothing much we can do right now. We have to do this vector very, very quickly. Let me delete this. Okay, 1 minute. Okay, so very, very quickly, guys, it will be a quick revision for you. Nothing much. Let me do one thing. Let me launch this computer. So this is Jenkins slave 3 cube new. Okay. This one, let me use better RAM and CPU. Okay. That is the right key pair plus 20 GB. I think I've given last time, maybe. Okay. That's all. And one more thing, guys, you have to do in this computer after you log in, you have to install 2 software. Okay. Let me do it manually, so I don't want to confuse you to make it automatic. So I'm doing the same thing. It won't take much time now. So this is a computer, and this system has some firewalls also. So let me enable the firewall. I guess things should don't work in one go mode. This is good always to learn new things. So enabling the firewall, so there is no issue connectivity from the Jenkins to the slave node. And let's go Jenkins cube new, this one. Let me log in. Only 2 prerequisites we have. And those know about a little bit about Terraform or AWS automation. Same thing you can do also automated. Okay. One thing we need is to install Java. Before they let me do one thing. I have to create a folder. Which folder? In the Jenkins, let me create a new node. This is a slave 3. Copying from the existing one. So save the time. And here you have to create this folder. There's by default creating this folder. That's what we're looking for. And one thing we need is to install Java. Say Y and Q. That's what guys done, right? And let me give the label to this guy's Kubernetes. Okay, label. and IP change because it needs the new computer. IP of this guy is this one. And what else you want? I think nothing. Click save. Okay, if you see the machines here, it should work in one go. Yeah, fantastic guys. In one go, the slave come up and your now everything is in sync. Fantastic, right? So that's very, very quickly we have come up. Only thing in the slave we need two things. I told you already. This is my slave. Let me connect to my same thing I take from this website. And first I will download this command. Okay, make this guy executable. Okay, and then copy this command to one of the location where all the command located. This is one of the location. So see, copy command. And to quick check also, this command working or not? Yes, working. And third thing, I need to copy the admin file here. And to get the admin file, you to go to master node. Okay, of the Kubernetes and say, so only IP change. And guys, by chance, everybody using the same account on AWS, so they can connect to each other through the private IP. So I'm using the private IP of the machines. So they have a local connectivity. So everyone belong to my AWS account, same account. If everybody knows not in the same account, you have to use public IP of this machines to connect. Transfer, fantastic. Config command. Okay. And admin config. So working fine. So I tested. My same thing, let me try with the Jenkins. So, and the job that I created right now, production to deployment, last time I was failing, let me build now. In the job to 3, say fantastic, they run very, very quickly. And they allocate to slave free and they run and get the output fantastically. It means my Jenkins is successfully connected to to Kubernetes. But this is not what I wanted here. What I wanted, whatever we have created in the test stage, in the test stage, okay, we have built an image and we tested an image. This is this image. I want this image to be launched in the Kubernetes. Okay. So how we launch? So again, if you know a little bit very basic command of the Kubernetes, the, the command is, okay, that I have this image, okay, the very basic command of the Kubernetes, and I want this image to be deployed, create deployment. And let's say my web is the deployment name. That's all. So there's one simple command of the Kubernetes. What this command will do, they will download this image, okay, and launch a deployment. That's called launch a container. That's called launch a pod. And because I'm running in the slave node or the user node of the Kubernetes, so for them, they have to log in one of the basic command of the Kubernetes. And, okay. Now what you will see here, if I just go to Kubernetes master node just to check, right now, okay, how many ports are running? No ports. How many deployment is there? Not, but when I run this job, okay, See here, they launch a deployment successfully. I can check from master node also. The deployment launched successfully and they launch one container, one port. Fantastic, guys. They're running perfectly fine. And to check it is working or not, normally in the queue. Okay. So service one we can go and expose to see the connectivity. It says kubectl, I want to expose my web, whatever name you give. Okay. Port number, my website is running on port number 80. And to type call node port. Node port is type means okay. So there's one we can do one time. Load balancer call service a one time. After service create, the IP in port number is fixed. Okay. It means if you want to connect to this port and want to see the website from the client perspective, come to this port number of the node. Means any of the node of the Kubernetes. So in the Kubernetes, a lot of computer running. Okay. You can pick any of the computers, they will work. Okay. So let me go to one of the IP of Kubernetes. This IP. And guys, all three computers become a cluster. You can pick any of the IP, and this is the Kubernetes cluster. And let's say I'm using this Kubernetes for production environment. So whichever IP you give to the client, guys, or URL, let's say take this IP address. And what a port number you give to the client, the port number is 3140. You can see the right. It's production environment. This is the IP and the port of Kubernetes. But who deploy the Kubernetes? Jenkins is the one who deployed the Kubernetes. And this is the production system. And now if you see the entire flow, now build is running the test is running the production. How I know? If I go to production, say, I am being run by test guys upstream. And tests say they have upstream downstream. So something changed the build, I will run. So I'm a test, for me upstream is build. But if I have successful, so everything is automated. Only challenge guys right now you see is okay. Again, if you go to my laptop here, do some changes here. Okay. And save. I again do commit. You get your program properly. Run. It will run sleep. But let's say after run they were successful or not. Okay. So they will run automatically. Everything will be automated. Okay. I just only upload for push for my Git from a local company. They first run the build job, then the test job, then this job. Everything is automated. I just check does this production job will run automated? Right, fantastic. But they will run out less. It failed. It failed. Run automated is nice, but it failed.
Recording in progress.
trying to create a deployment is already there. Allow. Okay. So in this case, there's two possibility deployment to create one more time. Okay, that is one thing you can do, or you can do a deployment strategy. And that is a fun part actually, but a lot. Right now, what I'm doing, I'm deleting the deployment and then create. It's not perfect way. Okay, but I'm doing right now. But tomorrow I will show you that deployment. No, okay. But right now, okay. Uh, Here in my last test, I am first deleting the deployment kubectl the deployment first and they get new. Okay, and now again I'm passing this file. This file it will always pass, otherwise command will run. So deleting the same deployment and then creating. Okay, that is a challenge. If you again run more that I have manually tried to run, then now they run successfully, and this is your production environment. New changes here. Okay. Now one last guys flow I would like to show you. I'm sitting in the laptop of the developers, and here I'm changing the 13, my lucky number, okay, and changing to a color like a violet, if violet colors, okay, and do some change here, last, and push. That's all. Entire process run automatically, and this is the process environment. In some second you will see end-to-end automation. And what is happening if I show you the entire flow, this is what happened behind the scene. Okay, this is what happened behind the scene. Okay, so developer upload on GitHub will uh, trigger the Jenkins automatically by GitHub webhooks. The build job run in slave node 1. After build job is stable, then test job in slave node 2. If test job was successful, we also write some test cases automatically. If they're successful, then they run deploy job in the production environment. And this job, they actually connect to the Kubernetes cluster. And this is the cluster where customer is connecting. Okay. And if are successful, you will see that will come up. So I'm at it was run successfully. And because it was running successfully, you can see they delete and run successful. Okay. But still you get the old output. Okay. Why? It is the same challenge, guys, what I show you in the Docker also. Because whenever in a Kubernetes download any image, they will download in local computer. If they found the image directly there already, they don't again download. If something changed the Docker Hub, they won't download. Okay. So what we have to do here in the Kubernetes, there's a concept called deployment pull image policy. Okay. It means every time when you do a deployment, okay, you can ask this guy that I would like to pull the image always. Okay. So maybe you can find a command also. Okay. So when you deploy, if this image is already there, they will use that there from the local storage of the Kubernetes node. It means they will always get the old image. If any new image can come up and change, they never come to know. So this image pull policy always you have to
Recording in
CTL
progress.
create deployment, see the help, and in the help they might be giving you an option. Okay, or if they does not give the option, so you if you know guys about Kubernetes, in the Kubernetes normally we deploy within some kind of file called YAML file. In the YAML file we can pass the options. We can pass the option every time. Okay, every time first download the image. Okay, this pull policy always, and then deploy it. That's what we can do. Command line does not have this option. Maybe you can try very quickly check. So kubectl deployment pull image in CLI command. Okay, if they have this option available in the command line. Otherwise, those who know how to create a YAML file. So in the YAML file, you can pass this option that will run the YAML file. They always, this is the option you can pass in the YAML file. And they always run, download this image first and then deploy. Okay, and normally we use the deployment file to run. Okay, so just you can try this. Otherwise, there's some more discussion to be yet to be discussed in this topic. So tomorrow class, I'll show you very quickly create this file and do the things. But this is the challenge only. Okay, this was the only challenge why you can see old version, but everything working automatically. That is a interesting concept. Okay, so that's it. Some more thing again to be I get to add in this today's project. Okay, one is this one what I was talking about. We will show you how to create the YAML file and very quickly run this. Second thing is uh, uh, the rolling strategies deployment. Okay, right now the way I'm doing the management here, okay, manual deleting is not good practice. Actually, it will have downtime in the production environment. Okay, so tomorrow we'll do some better study. Without deployment, any new version gonna come up, they will update. And for this, you will learn some extra stuff of Jenkins. It's very interesting concept. We will discuss in the next class. So same setup, guys, I'm going to use tomorrow. So tomorrow will be a continued class of that topic. But it's enough class, guys. Last 3 hours, I believe. So I keep explaining you, and step by step, we have done a lot of concepts and a lot of integration we have built. That's it from my side. See you in the next class. Okay, and that's all. We'll continue this project some more part in my tomorrow class. Any queries if you have, guys, you can ask me. You have some divine energy, sir. Thank you, Ayush. Everyone has actually. You also have. Anything else, guys? So in the payload URL, Vijit, I told you to give a Jenkins URL for the uh, Git webhook that I showed to you, right? So those URL you have to write in the GitHub. In the GitHub, go to project settings, not in this above setting here. Don't not go for this setting. Every project has their own setting. In the setting, okay, this is what you have to write. This is fixed always. Here you change, replace with your